In this gauntlet task, we are going to be using crossbows to try to hit Angry Birds. This crossbow is mounted on a track with a C-clamp, the red C-clamp you see here, and the track is mounted to the table with a table clamp. Now when you use these clamps, we can hold the ramps up, but make sure not to tighten them too much or you can damage that channel that the bolt goes through, because if you clamp too hard, this little area will be indented and you won't be able to use it for other labs. You can mount it in this orientation. Okay, so I have it on the kind of the wide side, so we can move this clamp back and forth, or we can mount it in this orientation. So you got lots of different choices. We can change the angle of the crossbow in this lab, and we have two targets. One target is an angry bird that's on the ground, right down there, and another target is one that's mounted in the air. So with different parameters such as height of the crossbow and distance from the crossbow to the angry bird, or the height of the crossbow, our goal is to basically hit the angry bird. In essence, we're using a 2D kinematic model to determine these distances and heights in order to hit the bird. I'll show you how to set up a Google spreadsheet for this, which is basically going to mimic the 2D kinematic model setup. So we'll do that here in a second. The Google spreadsheet model for the Angry Birds Gauntlet is similar to the previous ones, except we're going to be a little more formal on how we list our variables. Basically, we're going to list them in the order we would for a 2D kinematic model type problem. So we have x0, x, vx0, vx, acceleration in time, initial y displacement, y, initial y velocity, and so forth. And again, 99% of the time, these are going to be 0 here for the initial displacements, and for an object that falls below us, we'll have negative values. Okay. So we list the variables there like we did before. We have some calculations. In the side dish for this gauntlet, you're going to have to use some trigonomic functions. So I'll add in here angle here for the angle that we're going to shoot things at, and this is in degrees. And I'll say 45 degrees. Okay, but in order to do some trigonometry, we're going to have to use the sine and cosine functions, which take radians. So I'll show you how that works. I'll say equals, I'll sin, S-I-N. However, the number we need is in radians. So if I put in 45, that's going to be degrees. We need to convert that to radians. So I'm going to hold off on that. And I'm going to say angle in radians, or angle here in radians. And so I can say equals, now let's see, equals that number, the 45, times, now we want to say pi. It has a built-in, Google spreadsheet has a built-in value for pi, which is capital Pi, and I'm going to divide that by 180. So that'll effectively convert it to radians. Okay. Then I can find the sine of the angle, and cosine of the angle, the angel of the angle, which is now simply equals sin of that angle and equals cosine, cos, of that angle, right? So we get the 0.707, and again, if I change this angle here, I get 30 degrees. I'll get my 0.5 for the sine. If I go to 60 degrees, 0.5 for cosine. If I make it 0 degrees, I can see my sine and my cosine. If I go 90 degrees, I get my sine and my cosine. So I can type in my angle in degrees, which is convenient for us to measure, convert it to radians with pi over 180. Again, it's equal to the capital Pi with the open and closed parentheses, which is pi significant to a lot of decimal points. I'm not sure how many, but it's a lot, divided by 180. And then we have our sine and cosine. And then from there, you can perform your calculations, output values, and your tolerance level from there.